Hello everyone. In this video we're going to be solving a differential equation. We have y prime equals square root of x plus y and we're looking for y values. We're going to solve this equation for y where y is a function of x, and at the end we're going to check our work. So let's get started. I would like to use substitution here, so I want to replace x plus y with z. So we're going to start with that one. Z equals x plus y. From here, if you differentiate both sides, consider the fact that z and y are both functions of x. So the derivative of z, which we can call z prime, equals the derivative of x is 1, obviously, with respect to x, plus y prime. Now, this allows you to write y prime in terms of z prime. So let's go ahead and isolate y prime. Y prime can be written as z prime minus 1. So that's another thing that we're going to substitute into our equation. So y prime is going to be replaced with z prime minus 1, and x plus y is going to be replaced with z. Therefore, you're going to have the square root of z here. So this equation obviously is much simpler. Notice that we only have one variable, which is z. And then we can go ahead and solve for z and then come back here and back substitute. So to be able to solve this equation, first of all, this is a separable differential equation. First of all, let's isolate z prime first. So I can write z prime as square root of z plus 1. And then write the z prime as dz over dx, since z is a function of x. And then now we can separate the variables and just, divide both sides by square root of z plus 1 and cross multiply by dx. So we get dz over square root of z plus 1 equals dx. So, with separable differential equations, after separating the variables, we can integrate both sides to find the answer. Now, we're going to integrate both sides with respect to x, and, everything is basically a function of x. The integral of dx is fairly easy. But what about the integral of dz over square root of z plus 1? How do you integrate that, right? So in order to be able to integrate that, we're going to use substitution again. So let's go ahead and call this u. And then this gives us square root of z plus 1 equals u. And then you can just isolate the square root of z and square both sides. Our goal is to get to z and then to dz, right? So if you square both sides, you get z equals u minus 1 quantity squared, which you can leave like that. You don't really have to expand. Now my goal is to find dz, so let's d both sides. Okay, let's d both sides, and as you know, the definition for the differential is basically you take the derivative and then multiply by the d of the variable. So this is going to become 2 times u minus 1 multiplied by du. Great. Now my expression is in z, but I want to turn it into u. So let's go ahead and replace dz with this and z with that. We don't have a z, so we're just going to replace dz with that and square root of z plus 1 with u. Those are the two replacements we're going to make. And that's going to give us the following. 2 times, which I can write as 2u minus 2. 2u, if it's your birthday, happy birthday to you. All right, we're going to divide it by square root of z plus 1, which is u. And then obviously we do have a du because that's part of dz. Great. Obviously, I know that this is equal to dx, so I can go ahead and set it equal to the integral of dx, which is x, by the way, or x plus c. I'm going to take care of the constant at the very end. Now let's go ahead and separate these two things. Obviously, when you separate them or split them apart like this, integration is going to be much easier. And let's go ahead and integrate the left-hand side, and then we're going to set it equal to x plus c. So the integral of 2 is basically with respect to u. Got to remember that. We're integrating with respect to u. Okay, so it's going to be 2u minus 2 times ln absolute value of u. For now, we don't know what u is going to look like, so we have to use the absolute value. But later on, if we know the sign, like positive or negative, we can remove that. And obviously, this is going to equal x plus c, which is the integral of dx. Simple, right? Okay, fairly easy. Now, at this point, we can basically replace u with what it is. What is u? u is square root of z plus 1. Let's go ahead and do it. So we're going to get 2 times the square root of z plus 1. Oh, that kind of looks like an h. I don't like that. Just OCD. So 2 times the square root of z plus 1 minus 2 ln. Now notice that square root of z, when z is greater or equal to 0, this is a real number or real quantity. And square root of z plus 1 is never going to be negative, so I don't really need the absolute value there. That's basically unnecessary. And this is going to equal x plus c. But notice that we were not trying to solve for z. We were trying to solve for y. So we have to back substitute one more time. And remember, our initial assumption was that z equals x plus y. So I can basically replace z with x plus y now. Let's go ahead and do it. Replace z with x plus y. That's going to give you the following. I can basically, I guess I could distribute this, right? Okay. 2 times the square root of z, which is going to give you 2 times the square root of x plus y plus 2 minus 2 times ln square root of x plus y plus 1. And the whole thing is equal to x plus c. Remember, I promised that I was going to check the work at the end. So I'm going to go ahead and check my work now. So because notice that we kind of started off with a fairly simple equation, right? That was like y prime equals square root of x plus y. So it's a fairly simple equation, but can we get the same answer from here just by differentiating? So let's go ahead and check our work. To check our work, I'm going to differentiate both sides. But notice that it's impossible to write y explicitly as a function of x. Therefore, we have to use what's called implicit differentiation. And the implicit differentiation is basically you differentiate both sides with respect to x, treating y as a function of x. Therefore, when you differentiate y, it's just going to be y prime, and you're going to use the chain rule. So the square root of a function of x, basically, remember the square root of u differentiated is going to be u prime divided by 2 root u. So you have to use u prime as part of the chain rule. So this is going to become like 2 times u prime is going to be 1 plus y prime, the derivative of the inside divided by 2 times the same thing. So it's just going to be like that, and obviously 2 is going to cancel out, right? Okay, great. And then what am I going to do next? Plus 2, that's just going to cancel out when you differentiate, minus 2 times. Now how do you differentiate ln u? Ln u prime, this is going to be u prime over u. That's another rule for derivatives. So we have the ln of something. So we're going to write the u prime on top, which is 1 over 2 times the square root of x plus y. And obviously the derivative of 1 is 0, so I don't have to worry about it, divided by the function itself, which is the square root of x plus y plus 1. Awesome. And this is equal to the derivative of x, which is 1. Sweet. So let's go ahead and simplify this a little bit. 1 plus y prime divided by the square root of x plus y. And then this needs to be subtracted. Okay, the 2's are also going to cancel out here. Notice that 2 is multiplied by the, what's it called, the numerator. So we can kind of write this as minus 1 over square root of x plus y multiplied by the square root of x plus y plus 1. Okay. Now, we already differentiated, so we don't have to worry about differentiation anymore. And let's go ahead and check our work to make sure that we get it right. So 2 times, there was a 2 there, which came from here. Awesome. And then it just canceled out with the other 2. Okay, great. So this looks good. Let's go ahead and simplify this a little bit more. So we need to make a common denominator, obviously. And to make a common denominator, and I think we forgot something here. U prime should include, yes, exactly. I should actually use the same thing here. So it's supposed to be 1 plus y prime, not just 1. Okay, great. So this is going to be 1 plus y prime because I forgot to differentiate y. Great. Now we have a common numerator, but that doesn't help. So anyways, we can just, multiply this by this to make a common denominator. That's going to become square root of x plus y plus 1. And then minus this 1 plus y prime all over square root of x plus y times square root of x plus y plus 1. Sweet. Now I can actually factor this, so that will be super helpful. And of course, this is equal to 1. I can take out 1 plus y prime, and that's going to give me something interesting. Square root of x plus y plus 1 minus 1. Obviously, the 1 cancels out. And then we end up with something real nice, which you'll see in a little bit. I can just go ahead and now I can cross these out, and now I end up with something real simple. But let's go ahead and cross multiply. This gives us 1 plus y prime is 1 times the denominator, which is the square root of x plus y plus 1. And finally, the 1's cancel out, and we end up with what? Y prime equals square root of x plus y, which is basically the equation that we started with. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.